All right, I'm Chris Hardin, and today I'm going to focus on using Cloud Firestore to manage user state in a mobile app with serverless architecture. So first of all, Cloud Firestore is one of many products that are part of the Google Firebase platform. So I want to talk first a little bit about what is Firebase. So it's an app development platform by Google. It's built on top of the Google Cloud infrastructure. So it's kind of like a little subset of Google Cloud with kind of a more directed focus. It's really focused on enabling mobile app development primarily and promotes kind of a serverless architecture when using its products. So all the products are really designed to support you in doing that. It does support many languages, both server-side languages and front-end languages and frameworks. Provides nice SDKs and libraries for working from different technologies. There is a free tier, so if you want to get started with it, there's some pretty generous quotas for getting started with most of these products without having to enable billing or accidentally running up a big bill. Also, along those lines, there's a nice emulator suite that I haven't actually tried out yet, but I saw a demo of it. So there's an emulator suite where you can actually emulate a lot of these cloud products like the database and authentication and so on. You can emulate them locally to make it easier to test things out locally without worrying about incurring charges for one. Also, it supports running integration tests on like a CI/CD server. So just because all your stuff's in the cloud doesn't mean you can't do like local integration testing and good CI/CD stuff. So, and then also there's now an extensions marketplace. So if you're building an app and you're like, oh, I need in-app purchases, or I need to make thumbnails out of user images or something like that, these are things people have already done many times before. So you can actually go into the Firebase marketplace and basically, buy a plugin to do those things already. So you don't have to do everything from scratch. So there's a lot of stuff there to support app development. Again, it's a collection of quite a few products and services that you go in and you choose which ones you want to enable for a given project. So today I'm going to talk just about authentication and Cloud Firestore, but also some of the main ones are hosting. So you can easily deploy and host web apps in Firebase. And Cloud Functions is, excuse me. Cloud Functions, if you need to have some server code, so let's say you need to have privileged operations on your database or things you can't trust the client to do, you can use Cloud Functions. So a Cloud Function is a single-purpose JavaScript function running in a managed node environment. So you don't worry about the details of spinning up a node server. You just write some JavaScript and it executes in the cloud. And so you can do privileged operations using a special admin SDK to Firebase there. There's also storage buckets for storing files, and then a whole bunch of other stuff. I've mainly worked with the first 5 here. These are the main products. There's a lot of other stuff out there, analytics. This Crashlytics thing I saw a demo of on Tuesday. It's pretty cool. It can track crashes in your app from users using it and kind of give you metrics and help you like drill down to what's going on and solve problems and stuff like that. So that looked really cool, but I haven't actually had a chance to do that yet. Okay, so I want to talk about Firestore, which is my database and storing data. But before I can set up a database, I really need to have some sort of authentication to protect that data. So I'm going to start with authentication first. And so, Firebase provides an authentication platform. It's really easy to set up and manage. You can onboard new users very easily. You can just give a registration button on your app and they can sign themselves up. It's really easy to do. They provide an SDK so you can write your own login screens and do all your custom stuff that you want. Or there's also libraries, UI libraries for various different platforms and frameworks so that you can just drop in a whole login flow if you want to do all this stuff. You don't actually have to do it yourself. So that's really nice to get going really quickly with. And then also it deals with things like persisting user authentication when your app restarts. So whether you're on a native app or a web app, it'll handle the details of persisting JWT tokens and doing that between app reloads. If you pay for a higher tier, it also integrates with Google Cloud Logging. So you have kind of enterprise grade logging for activity tracking and auditing and things like that. And it supports many different authentication mechanisms. So the simplest thing is just email and password. So inside the Firebase Cloud Console, you can see your users and their email and password and do password resets and stuff like that. It also supports phone authentication for like texting, users a code, multi-factor authentication, integrates with industry standards like OAuth 2 and OpenID Connect, so you can integrate with just about anything. And then it has a built-in support for other federated sign-on solutions like Google, Twitter, Facebook, etc. And then if you're trying to do this, in an enterprise and you already have a big custom sign-on solution, you can also integrate with that. Because if you're going to use Firebase services, you kind of need to have a Firebase auth token to easily interact with those. So you can actually take your custom enterprise sign-on solution and programmatically get a Firebase token for each user. So you can integrate with whatever you have and still be able to access Firebase services easily. Again, those are all just JWT tokens that get generated. Okay, so the main thing I wanted to focus on, though, was Cloud Firestore. So Firestore is a NoSQL document database provided as part of the Firebase platform. And specifically, it's a document database that's optimized for storing large collections of small documents. So sometimes when you are going to model data in a document database, sometimes you end up with large documents that are a result of taking your data, your hierarchical data, and flattening it out, denormalizing it. And it's kind of hard to manage relationships in those documents sometimes. So Firestore kind of takes a different approach. It's got a very flexible structure and allows for nested sub-collections. So you don't want to flatten out your data. You actually want to keep a hierarchical structure by having a document reference nested collections. And that means that allows you to keep your documents small. So it also has support for, I could have a document and I could put arrays or maps and objects in there and make complicated documents and structures. But it's optimized for working with smaller documents. So you don't want to do anything that's going to cause that document to get really large. If you have an array of items, it's going to grow to be something large over time, or it's not a fixed size. You probably want to model that instead as a nested collection. So you're only retrieving small documents, and then any relationships are represented by these nested sub-collections. And for me, that actually made it really easy to think about my data, because that's how I'm used to thinking about it, as relationships between objects, relationships between documents, instead of trying to flatten it out into one big structure. Yeah.
What's very large?
That's a good question. I don't know what the definition of large is really, but I'm just writing a little mobile app, so I just have a little bits of data. So I don't.
Like kilobytes or less than megabyte.
There is a limit on the size of a document. I don't remember what it is. I mean, I'm sure it's sufficiently large to do most things. It's just, yeah, sorry, I don't have the exact answer for that. But the idea is to model it in such a way to prefer nested collections versus just documents that may grow exponentially or something like that. It does support up to 100 levels deep of this nesting. So you can do really complex structure. Yeah, so you can have multiple root level collections for unrelated data sets. And then within each collection, each document can have a nested subcollection, one or more nested subcollections, and those have documents, and then those can have nested collections. So you can have a nice organized tree structure. So again, the idea is that you can do that instead of trying to flatten everything into a large document. And it's optimized for querying it that way. It does support fast expressive queries, so you can do where queries and things like that. The caveat there is it's fast because it enforces the need for indexes. So if you haven't defined an index across the fields you're querying on, you can't do the query. It's errors out. So in some apps, that's perfectly fine because it does provide a lot of support during development and testing. So when you're testing your app, if you hit a query that you haven't defined an index for, Firebase gives you a very helpful message that actually has a URL that actually will create that index for you. So it defines what index you're missing. It's like, hey, do you want to create it? Create it. Now, obviously, you don't want your users doing that, right? So the only time I ran into problems with this is we were working on an app and we were told you must use Firebase just because, right? Or Firestore, just because, right? Somebody decided they needed to be using that technology. And in this app, we had like a complex table with dynamic columns and very complicated sorting and filtering that they needed to do. So obviously that was a bad use case for Firestore because there was no way we could predefine all the indexes before we took it to the users, right? You have to have only be sorting and filtering and sorting on fields that you can define up front, right? If you're combining them. You can filter on single fields. It automatically creates indexes for single fields. Every field you add, it'll automatically create an index for it. It's just when you're combining more than one field in a query or a sort. Another thing is missing is aggregation functions. So you want to do like count or sum. So they just announced that they added a count function on Tuesday. They had a big Firebase summit. So now before you actually had to like, hey, give me all the documents where something is true, and then now count them in your code, which seems kind of silly. Now you can actually just ask the server, hey, how many documents match this? So that's a big improvement. So they're working on adding more aggregation features. Right now, that's like the only one. So if you're going to be doing a lot of aggregation stuff, obviously, this wouldn't be right for you. But in my case, I was just looking to create a mobile app, and I wanted to store data for a particular user, and I wanted to structure it into different collections. So this was a real win for me. And I'm going to show that app in just a minute. The last bullet here at the top is Firestore right for you? So there are many database choices out there, of course. Firebase itself actually provides two different databases, real-time database and Cloud Firestore. They both have this real-time support. I'll get into what that means. Cloud Firestore is actually the newer one. So it's kind of an evolution of the previous one, but it's Google. So every time they come up with something new, they don't get rid of the old thing. They just make the new one slightly different, and then they sell them for different use cases. So it's like Cloud Run and App Engine, like they do that all the time. So we still have two products. They're both NoSQL databases. They do have a different structure of the data. So real-time database is more of a JSON tree, whereas Firestore has these nice small document collections. So I chose Firestore because I liked that data structure. They both have this kind of real-time streaming support for the apps. They're both built on top of Google Cloud. They do scale differently. Firestore is actually more scalable than, or easier to scale than real-time databases. But Google does provide this whole little kind of choose your own adventure where you answer a bunch of questions, and then it tells you which one's right for you. So, okay, so other than document structure, what's really cool about Firestore is it's made for serverless apps. And what that means is the database itself has a lot of support for doing things like enforcing security rules based on user logins and things like that. So the idea is so you don't have to write a backend server app to do your logic to protect your database. You can actually do all the interaction with the database from the client code. And in addition to that, it provides a local cache on each device. And so this local cache kind of gives you all this local state management for free. And it handles things like, if you have multiple devices, say your user's logging in from multiple devices, it can sync up changes across those devices. And if your device goes offline for a while, your app can continue to work against the local cache. And any edits are stored there in the local cache and will automatically synchronize as soon as the device goes back online. So particularly for like a mobile app, that's really useful because you can't guarantee a solid network connection all the time. So it's pretty seamless. And in my experience, I spent a lot of time writing Angular apps with Redux, which is a huge pain. So I've spent a lot of time writing like large enterprise apps and doing a lot of local state management in my web app and building up like a whole internal data structure in my app. And when I went to build this app and I used Firestore, I didn't do any of that. So I know Flutter has lots of different, so I wrote an app in Flutter. Flutter has lots of different state management approaches, and I didn't use any of them because I didn't need to. All my stuff's in Firestore. And so the Firebase Firestore SDK kind of gives me all the local state management I need. And so if you think about it, that local cache is really kind of that local state management for me. I didn't actually have to build it in my app. And we'll kind of see how that is. So again, it does provide SDKs for accessing it from web apps, from native mobile apps. It also provides server SDKs in case you do need to do some sort of privileged operation that you just can't manage through the security rules. So you can, access your database from Cloud Functions or a server app if you need to. But you can do a lot just from the client using the client SDKs. You are billed by the numbers of reads and writes. So each document read or document write or even delete, which seems funny, but even a delete costs money. Though we're talking, you know, fractions of pennies for thousands of documents. So you are billed that way. However, the fact that you have that local cache can mitigate that some because you're not constantly hitting the server. You do have local documents cached. Also, they encourage you to not just fetch documents, but actually ask for a stream, okay? And so a stream is going to give you a document up front, and then as changes are made to a collection or to a document, it's just going to send you the deltas. So let's say you execute a query and say, give me all of the documents where city is St. Louis. You're going to pay for the initial read of those documents, but then if more documents get added and you're still listening to that query, you're only going to pay for the delta. So if somebody adds 5 new documents, that's 5 more document reads. You don't have to re-execute that query and then incur the cost of reloading all of those documents. So it's important to use it in a streaming way to make your app more reactive and faster, but also to avoid unnecessary charges. Let's see. Yes.
How long does that persist, like the stream? Would it be like so they reload the app or?
I believe it's locally there on the device in the local data. So to get rid of it entirely, you'd have to go into like your device settings and say clear out the data for this app. But it has like a time of when you're like executing a query or pulling a collection. I believe it has a time of 30 minutes. So if the data is more than 30 minutes old in the cache, it'll go fetch the fresh. I read something about that. So so it kind of has a lifetime of about 30 minutes, but is on the device. That makes sense. Sorry. Yeah. So it's a little complicated, like when it goes to cache and when it doesn't. But yeah, if you execute a query and it's more than 30 minutes old, it will pull the whole thing fresh. Let's see. But like in my case, I was worried about, okay, I'm navigating back and forth to screens in my app. Am I like repulling all this stuff all the time? And it shouldn't be doing that. It's going to hit the cache. Let's see. And again, this integrates with Firebase authentication. So I'm going to control how users access different data, different documents, all using security rules in Firebase. I don't have to actually write a server or do any of that in the client, which would, of course, be untrusted. OK, so I'm going to demo my little app. It's horribly ugly. OK, UX is not my thing. But here we go. Let me go back to the beginning. So here's my beautiful login screen. So I did not use the Firebase UI stuff. I will probably go back and add that in. But this was really quick and easy to get going with. And so I just have the one screen. You can either log in or register. And so actually I can, so if I just type in any sort of email and password, and again, it doesn't have to be legit because I don't have email verification turned on. You can enforce email verification. Yeah, with like click this link, and Google handles all of that. Yeah, I'll show that a little bit in a minute, like where you see those email templates. Okay, so here, this is a new user. They just downloaded my app, and they're like, oh, yeah, let me register. And now an account has been created for them in my Firebase project, and they can get started. So that was pretty easy. I'm going to log out, and I'm going to log in with an actual user. And my actual email address is really long, so this has been kind of annoying. Oops. Okay, so I'm going to log in. Okay, so I just logged in as a real user, and here I have my dashboard. So there's lots of things I want to do in life. Like I want to do push-ups every day and practice karate and learn a new language, and I never get around to doing them. So I'm like, I'll write an app that just reminds me, hey, you should be doing this stuff, right? We'll see if it works, right? So, so here on the dashboard is a list of things that I want to do, right? List of reminders. So right now I have 2 of them. And so this screen is actually asking for, asking Firestore, hey, give me the collection of reminders for this user. And I'm getting it back as a stream. So as changes are made, this screen will automatically update and everything is So actually I have it running here on the simulator. Then I also have it running on my phone, and I'm logged in as the same person. So if I go into here and I add something, minutes. Sorry, this is taking too long. Okay. So I add something. You can see it immediately popped up over here. So it's constantly streaming changes. And again, I'm always just getting the deltas, not paying to repull that collection every time. And so here, this is using Flutter Streams because this is a Flutter app. If I was doing it in the web, I would use something like JavaScript. It would be observables, something like that. I'm an RxJS person, so I would use RxJS if I was doing this in a web app. Okay. So here I have one collection. So I logged in as a user. I use that user ID to identify what collection I'm going to pull for reminders. And I show them here in the list. Once I click on one, and these are not real entries. Once I click on one, I can see information about the reminder. So what is my goal for it? How often do I want to do it? Any notes? So these items at the top, these are things that would be in the reminder document, right? But the whole idea of this is to remind the person to do something, and then they can log an entry to say that they did it and record how many they did and so on. So top half of the screen here is information from that one document. And then the logs here that you see, this is another collection. So this is a list of log documents for that particular reminder. So I've got a user, the collection of reminders. Each reminder has a collection of log entries. And again, I'm using that same streaming mechanism. So if I were to come into here and edit the top entry, so you know I actually did 30 push-ups, you can see it immediately updates on the screen. And here I can add them to the list and edit them and so on. And so as I'm editing and adding things, I'm writing all of that to Firestore. It first writes it to the local cache and then to the server. And any of these streams that I have set up, so every time I go to a screen, I'm generally getting a stream, either a stream of documents or a stream of changes for a single document. And so I'm always listening to these streams so that anytime an edit is made anywhere, that stream updates. And when you're making local changes, your stream, so I'm making a local change on one screen, and I'm listening to a stream on another screen, right? Because this is Flutter, so we're just kind of stacking screens on top of each other, not really going away. So, you know, back here on here, I still have a stream of reminders. If I add a new reminder, it's going to go into the local cache, and my stream is going to automatically update. It doesn't actually wait for it to go back to the server. So it's a little faster that way. And also that allows it to work if I'm offline. So, and it will eventually sync up to the server. If you actually care about whether it's been synced to the server or not, you can actually get that metadata. So when you get an update, you can actually ask to know if it's actually been committed to the server or not yet, if that's important to you. But so it all kind of happens quickly. And as someone who's done Redux a lot before in my web apps, you know, I like immutable objects and things like that. So whenever I pull these collections or documents down, I'm just taking that data and putting it into an immutable object. And every time I go to a new screen, you know, I'm creating a listener and listening for changes on that directly from Firestore. So, sorry, that's not making any sense. But so like when I click on, let's say karate here, you know, I have a karate document right now. I could just pass it to the next screen, and I actually am. But if I just displayed its contents here, it would be very static. And so I actually here ask Firestore, hey, give me a stream of changes for that object. I don't reuse it. Yeah.
So when you said previously that the logs for a collection, is that like an array inside your karate document, or is it like is a collection another bucket?
Yeah, you know what? I was going to show it later, but let me just bring it up. So go. So if you just type in Firebase like google.com, that just takes you to the docs. And you click console, and you can go to the Firebase console where everything's organized into projects. Okay, we'll get back to your question. This is just based on your Google login. So if you have a Google login, you can just open this up and start creating projects. And it'll automatically do it on the free plan. So you can create one here. I'll do that in a minute. So this is the one that for my app. So I can open up here in the console, and I can go look at the data. So here on the left, if I click Firestore database, we can actually just see all my collections. So here, my top level collection is user, so that's a root level collection, and you can have multiple root level collections. I only have one. So I just wanted to have all my data be segregated by users. So, so at the top here, for each user, I have a document, and the document ID is actually their Firebase authentication user ID. So that makes it really easy for me to retrieve stuff. They log in, I grab that ID, and I get a collection. I get a document. So once I have the user's document, let's see, is this, let me find the one that actually has stuff in it. Okay, so you can see like here's the one that I just created when I entered in that foo email. I'm trying to find the right one. Okay, this is the one. Excuse me. So this is my star number 31. So here, this is the user document. And so in Firebase console, you can see fields that are actually in the document. So this just has a name field with the value Chris, and that's it. That's the only thing in the document itself. But then it has collections, and you can have any number of collections. So it's an actual real collection. It's not part of the document. It's and actually, even if you delete the document, you have to be careful when you delete documents because it doesn't automatically delete subcollections. You have to like go delete the subcollections first, then delete your document. So it really is like a separate thing, but it's easy to navigate too. If that makes sense.
That order, or is it problematic?
It is problematic. If you delete the document first, it's hard to delete the subcollection. Yeah, I actually did that first because I didn't know any better. And so I know what it looks like. So if you go into the Firebase console, like, so let's say I deleted, let's say I deleted this document here, right, for the user. If I came into the Firebase console, I would still see this ID number, but it'd be like in italics. And so it's like this document doesn't exist, but you can still navigate to its subcollections. So I would actually still see the subcollection here, but I wouldn't see anything in fields, and this would look weird. And it's not a great situation. It's not terrible, but you want to avoid it. So you definitely, that's kind of like one of the things about adding subcollections. You have to be careful about deleting the data. So I fixed that simply in my app by deleting the subcollection and then deleting the thing above. Sorry, getting back to the original question. So yeah, so this user document has a collection of reminders. And so I can just navigating, again, I can go 100 levels deep with this. So this document has some, let's see. Wait, here's the collection. It's a little confusing. This is the collection. These are the documents in the collection. So if we can find one, let me find one that has entries. Here we go. So here's my push-ups entry. So here's the fields in the document, the title, the goal, etc. And then here is the collection of logs. Okay, so these are documents just like any other document in a collection. You can actually do queries and things across collections. So like every reminder has a log collection, and every user has those. You could actually do queries that cross all of those subcollections. Like I want to look at everybody's logs for push-ups. You could do that, provided you have an index to hold. So here I have all the individual log entries. So you see here I have the fields for that document, and I can go in and start more collections if I really wanted to. So I can create a collection here, or I can just create it in my app as well. So creating a collection or a document is really easy. You just ask for it, and if it exists, it gives it to you. If it doesn't, you can just create it. So it kind of just creates them on the fly. Yeah.
So is this where you specify the schema by adding the fields right there, or can you do that?
There is no schema. So these documents don't have to have the same fields at all. So I can create a document right here and add stuff, whatever I want. And in the code, I could create a document and add completely different fields. I'm not going to do that because that would be chaos, but but you can do whatever you want, right? So yeah, and in fact, if we look at the user, yeah. Hold on, how do I get back? Wait. There we go. Okay. So and actually, so this first. Yeah, right. So if you look at this first user, the one that I'm like all my stuff in, I created this before I created the app, right? So I'm like, how am I going to do my data? So I created everything, typing it in here, and I added fields. So you can see that this one looks different than the other ones because I didn't know what I was doing. I was like, oh, I'll just add a random field, added the name field. And then later I was like, oh, I actually need my app to create these user documents. I was just skipping that step. So I added that. And so now the rest of them all have the same structure because my app is creating them. And so they have the email address, which I really just put there just to have something in there.
Say they have the same scheme.
Yeah. But yeah, it is schema-less. You can do whatever you want. Obviously, you want to have some structure or else it's going to be chaos.
By your app.
Okay. Yeah, so you can directly create everything in here or from your app. Okay, I'm getting yeah, I thought it was great, especially since it totally mimicked what my app needed to do. Obviously, it's not going to work for every use case. You should always pick the right tool, right? But based on how I wanted to structure my data, this made a lot of sense. And I didn't want to have to worry about a local state management framework or any of that. So it's just like, oh, this just kind of takes care of everything for me. Okay, sorry, now I gotta remember where I was at. So I think I kind of talked about all the bits there. So yeah, so now I was just gonna go ahead and show what it's like to set up a Firebase project and look at my existing one a little bit more. So again, you start off by going to this Firebase console. And again, all you need is a Google login. And I'm already in mine. Let's see if I can get back. Yeah, okay, so this is what it looks like more when you first come to the page. And so if you want to add a new project, you just click Add Project and give it a name. Let's see if I can use this one. So I can call it whatever I want, and it's going to create a unique identifier down here. And it's like, hey, do you want some analytics? You can turn that on or off. I don't.
Always keep it on. It's free.
Yeah, it's free. It's free.
Just keep it on.
It's free. Okay. 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 So I honestly I've never used the analytics features. I just click through this. So so here we can have an account. Okay, let's get past this. All right, so we're creating a project. So it's going to create this project, and nothing's really turned on in except for analytics, but it doesn't actually do anything until we and we add some services. Hopefully it won't take too long to provision this. Just take a minute. Yeah, right. Okay, so here we're ready to go. All right, I got a project. There's nothing like enabled in it, and I don't have any apps associated with it. So you're going to actually register an app with your one or more with your project. And so that's what it's talking about up here. It's like, hey, let's get started. Do you have an Android app? Do you have an iOS app? Do you have a web app? Let's figure out how to add these to your project. And I'll do that in a minute. The other thing we need to do is actually add some products and services. So what do we want to use? We want to use authentication, and we want to use Firestore. And so they have these products grouped into 4 categories. And honestly, I'm really only familiar with the ones under build. So here we've got authentication. We've got both database types, cloud storage, hosting, and cloud functions. Those are the ones that I'm familiar with. Right now, I want to turn on authentication. Okay. So yeah, let's get started. And here I can just choose any number of providers. So I can do Google authentication, things. I'm just going to do email and password for right now. So I'm going to turn that on. Okay. And there's some other features down here. Okay, so you can add another provider. So you can add Google sign in or whatever. Right now I'm just doing this. And we talked about like password reset emails and email verification emails and things like that. You can control all of that up here. So under templates, you can see it's going to send emails out to your users. And it's really funny because this is a Google product and I use Gmail. So if you leave like this from address, it'll go right to spam. Like Google totally blocks it, right? So I'm like, it's not working. Oh, no, it's in spam. So because I kept forgetting my password when I'm testing my own app. So I've done the password reset multiple times. So yeah, that totally goes to spam, but you can actually change that to do something that looks more legit than firebaseapp.com and totally change these templates and various other things and turn on email verification and stuff like that. No, this is all built in, this part. So most of the stuff is relatively free. Now, Google Cloud itself has something called identity management, which is a more enterprise level kind of user management. And so you can upgrade Firebase authentication to be Firebase authentication with identity management, and you get kind of more enterprise grade features, and then that's where you're going to start incurring more costs.
I also think you get 50,000 users for free. With Firebase.
Okay, yeah. I've never never had to worry about more than that. So,
Like all 0, right? You get like certain okay.
I think Auth0 is 20,000. So Firebase, and then it's like after that, it's like 1,000 for 10 cents or something. Like it's ridiculous. Come on, I mean it's ridiculously reasonable. So I think as you get started,
Well, that's awesome. Like 0.
yeah.
When they say that like P1000, that's the users, like unique users per month, right?
I think it's yes.
Right? Okay.
Or
Or is it
I think it's total users.
so every time somebody logs in? That'd be
No, every time someone signs up, that's a new user.
yeah.
In your system.
So
Yeah,
there's
okay.
5 already.
Just trying to figure out where the here's usage limit.
So only 49,000.
But what Chris could be doing is Firebase provides the like the emulation services, so you could just spin those up on a computer and
Yes, that's true as well.
I don't really know.
Yeah, but I mean, if we're just testing your app, there's plenty of free stuff, right? But yeah, the emulators can do that as well. What's cool about the emulator is then you can like really test different authentication scenarios and different providers and stuff. So
Yeah, that's
Um,
really
I haven't had a chance to play with it yet. So, oh yeah, so I was trying to find, usually in the docs for each product, they have like the pricing and stuff explained. So I was trying to find that. I didn't see that immediately for auth, but we have the limits and things like that. So
awesome.
yeah, it's fairly high. Again, you can always upgrade to the Google Cloud version. So again, like Firebase is kind of this weird little subset of Google Cloud, and like Firebase has cloud functions, Google Cloud has cloud functions. They're really the same thing. It's just they kind of put all this stuff together into this kind of Firebase suite for a very targeted audience. And it has kind of different pricing plans and stuff. But you can always, it's easy to kind of scale up to the full Google Cloud. Where was I? Okay. Right, so that was just showing the templates, various settings and things like that. I can manage my users right here. So I can actually just literally add a user here, or as a user goes to my app and hits register, it'll just automatically create them here. And I'll show mine in a second. So that's authentication. Now I need to turn on Firestore. Oh, I'm running out of time. Okay, Firestore. Again, they're like, are you sure you want Firestore? And then I'll walk you through choosing between the two. Then you just create a database. Here, it's going to bug me about security rules. So you can start off with either everything open or everything turned off, and then modify your security rules later. Because again, you're accessing everything from the client. There's no secret keys. Everything is public. So you really have to make sure that the rules are properly defined on the database. Okay, so, and then, oh yeah, you have to choose a location. So once you set the location, that location is set for every service in your Firebase project. So here, let's set it to US Central, and then it will do that. And then hopefully, anyway, let's see if I can. Yeah, let's move on here. Let's see if I can get to my other project. Okay, so you can see it created this new one here. So let's look at my existing one. Okay, so when I load my existing one, we've already looked at my database stuff. If we look at authentication, you can see all the users that I've created. Shows when they signed in. And here, if I need to reset my password, I can reset the password here, and that will trigger that reset email. Or I can disable or delete the account. So I can do some basic user management right here. Okay, so once I've got the project set up, I need to set up my app. And so if we go back to project overview, here we have these things called apps. And so you can see I actually have an iOS app and an Android app registered. That's because I'm using Flutter. And so when I set up my Flutter app to use Firebase, I said, which platforms I was supporting. And so it actually registered an individual app with Firebase for each target platform. It doesn't show web because I didn't choose web when I was building it. So to add an app, you can just select what platforms. You can see we have native iOS, Android, web, Unity, and Flutter as the ones they provide. If I click on, I'm gonna click on the web one actually, because it's the simplest thing. So if I want to do a web app, this is really simple. So I can do this. You can set up Firebase hosting for a web app. I'm not going to do that right now. Once you hit register, okay, this is going to show you, this is how you set up Firebase for your web app. Really simple. You do an npm install Firebase, and then you copy and paste this into your JavaScript code. And so, and this is going to be very similar for Flutter as far as the actual configuration goes. So this bit here, this is what actually configures how your app talks to Firebase, which again is why the security rules are so important, because all the keys in here that you see, like this API key, these are all public. You can put these in your client. They're available on the web. You can put it in version control. None of this is secret, okay? So anybody can make these requests to your Firebase project. So it's important to do the security rules on the server, because you're not going to be restricting that from the client side. But again, these keys look kind of scary. They look like they shouldn't be in version control, but it's totally fine. And you're just going to be serving them up in JavaScript. Anybody could pull down. So, so basically, yeah, you copy and paste this into your app, do a couple of lines of initialization, and then you're good to go and use the Firebase SDK from a React app, an Angular app, any kind of JavaScript application. Let me kill this one. For Flutter, Flutter's a little more complicated. But basically, and I'm going to kind of try and speed this up. First thing you're going to do is install the Firebase CLI on your machine. So it's going to have a lot of commands for deploying and building, configuring things. And then you're going to install the Flutter SDK. Wait, this is just actual Flutter. Oh, that's actually installing Flutter. But yeah, create your Flutter project. All right. So install the Firebase CLI, and then you're going to install the CLI that's more specific to Flutter in Firebase. So it's the Flutter Fire CLI. So the Flutter Fire CLI will handle all the details of figuring out how to configure your Flutter app to actually work with Firebase. So you don't have to do all this configuration yourself. It's going to be like Flutter Fire configure, something like that. And it asks you a bunch of questions, and it registers everything for you. And it's actually pretty simple. Oh, yeah, here it is. Okay. Yeah. So you're going to install the Flutter Fire CLI and tell it to configure your project for you. And then it will show up in your console there. So let's skip ahead a bit here. So going to my code. Again, this is a Flutter app. I'm trying to talk through it in an agnostic way, hopefully. So again, for a web app, you just copy and paste that Firebase config it showed you into your app. In a Flutter app, when you run that Flutter Fire configure, it's going to create this Firebase options file. And again, you see we have the API keys and all that stuff in here. Okay. And so there's the configuration file. And then in our main file, we simply need to initialize Firebase for our app. And that's pretty much all we have to do to get it set up. And then in our app, when we need to access a Firebase feature, we can basically just access a singleton reference to the things that we need, to the auth instance or the Firestore instance, and do whatever operations we need to do. So it's really easy to wire it into your app. And let's see. Yeah, I'm running out of time, so I'm going to skip straight to the model objects that I've created. So I have users, I have reminders, which I just call minders, and logs. So for each of these, I created a model object that holds the data, but then also has static functions for doing all the interactions with Firestore. So all of that interaction is encapsulated in these model objects. So let's start with the simpler one is the user. And again, this is Dart, but the web SDK, web APIs are going to be very similar. They're just going to be using observables and things instead of Dart streams. So let's see. Okay, so first of all, I have an immutable model object, the ID and an email. So that's simple. I do have these two functions here to handle marshalling and unmarshalling from JSON or JSON-like structure. So as I'm getting documents from Firestore or sending them up, I can marshal and unmarshal them to my model objects for my app pretty easily. And Firebase will actually do this for me. I just have to give it these two functions, which I do down below. So to do anything, I need to first get a collection. So if I skip down here to my get user collection method, I'm going to access Firebase Firestore.instance. So each of these products, you're going to have a different singleton instance that you can access. In a web app, there's a function that you import to say get Firestore, get auth, and it just gives you that reference. So this gives me access to Firestore, and then I just ask for what I want. So the first thing I want is the users collection. So I say, give me the collection users, and then with converter. So this is where I plug in my two functions to convert to and from my model objects. So this is going to return a collection reference. And then any operations I do on this collection reference, it's going to automatically use those converter functions for me. So now I can just work with model objects instead of worrying about these maps and JSON and stuff. So I'm defining this kind of generic get user collection, and then my other functions in here use that. So if I want to add a new user, I call this doc method on the user collection and pass in the ID. And so this creates a document reference. It doesn't really create the document yet. It's just a reference. And if that document already exists, it would be a reference to the existing document. But this one doesn't exist yet because I'm adding a new user. As soon as I call set here and pass in my user object, the set method is going to cause that new user document to be created. And if one already exists with this ID, it will get overwritten. So there's set and there's update. Set is actually going to overwrite it if it already exists. So, and that's it. And I have my user object. Let's see. To get a user, it actually looks exactly the same. Well, here I can get a document reference to the user. And from there, I can get a snapshot. So this document reference is not actually a document itself. It's kind of like a handle to it. And then from there, I can say either get me the actual contents or get me a stream so I can listen to document changes. And to get a stream, it's called snapshots. So like if I do this, that will give me back a stream of the document changes. So I get the initial contents of the document and it keeps getting updated. And there's a different method. Let's see, I think it's down here. Yeah, if I just call get, then I actually get one single in-time snapshot of that document as it is right now. And then we have the update. Okay. And so the API for working with a document versus working with a collection, it's very similar. So I can, again, even with a collection or a document, I can either ask for, give me the static snapshots right now, or give me the stream where I can get them over time. So in the user, I don't have that down in my Minder object. I want to show that updating list of reminders on the dashboard page. So here, this one is a little more complicated. Let's see. Get Minder collection. Here we go. Sorry. So here I have a stream for user method. So here I get my collection based on the user's ID, right? So I'm going to find my Minder collection based on the user ID, and then I can order it. So I have a display order field on each reminder document that I added, so I can order it by that. And then I say, hey, I want snapshots, and this is going to give me back a Dart stream, or it'd be some sort of observable or something in JavaScript. On this get Minder collection, this is a nested collection, so it looks. So look at this first part. Oops, sorry. This first part is exactly the same as we saw with the users. I'm just repeating that part. And I could make this more dry if I needed to. So first I get the users collection, a reference to the users collection. Then I get a reference to a particular user document. And then I say, okay, I actually want the Minders collection for that user document. And I'm not actually pulling down the user document. I'm just kind of building up a path to the collection that I actually want, which is the Minders collection for that particular user. And then here I can plug in the converters for a Minder object. And then if I go to the log model object, you'll see the same thing where your users and then navigate down to a particular log collection. And so you always have this pattern of collection doc, collection doc, collection doc as you're navigating through the hierarchy there. Okay. Yeah, and so again, we have all the CRUD operations here. You can add one, update one, and then here we can simply get a reference. If we go on those document references, we can just call delete, and it deletes it from the collection. And this is that bit that I was talking about that I initially didn't do. So if I want to delete this reminder, I have to first explicitly delete the logs collection for that particular reminder, and then delete it. Otherwise, it leaves orphans.
Cascade delete.
No, there isn't. There's also, it actually tells you not to do this at all in the documents. In the docs, it's like, don't delete collections from the client. I know my collections are gonna be pretty small. But if you like have large collections, they want you to do that from like a server method or something, or a cloud function. Yeah, because they're worried about the performance of deleting whole collections from the client. I guess it doesn't do it very efficiently. So in this case, I'm like, I don't think my log collections are going to be a big deal. So I just did it this way. This is the easy way. Yeah, sorry, I'm running out of time. So I'm trying to remember if there was something else specifically. Just the other thing. So with the users, I had a clear ID for each document. I wanted to use the user's authentication ID so I can easily map my user to my data. But for the reminders and the logs, I don't have a good ID candidate. So I can easily just have Firebase auto-generate IDs for me. And so the difference there, when I add a document, yeah, it's just a different way of calling it. So instead of saying doc and then set, I just call add and pass in my model object, which does not have an ID field in it. And so when I do that, Firebase will automatically create an ID for me and assign it. And one thing that's important about that is if you have IDs that are lexicographically serial, it causes hotspots in the database. So like if your IDs are, foo1, foo2, foo3, it's going to cause a problem. So when you auto-generate the IDs, Firebase has a scattering algorithm it uses to make sure that the documents are distributed so it doesn't cause hotspots in your database. Okay. So I only have like 5 minutes left, so I'm going to go ahead and stop talking here. Are there any other questions?
Something updates further, if you don't, reminder object doesn't have, like, I guess you update the screen.
Yeah, so the ID is not really part of the document. It's part of, yeah, and I messed up. So I accidentally included the ID in the document I was sending to Firestore. And so what I ended up with was like a field called ID that had nothing to do with the actual ID of the document. I just had a duplicate redundant thing. So if you notice, it makes my model object mapping look a little weird. So like if I look at my users, my user has an ID field and an email field. But when I say to JSON, I explicitly leave out the ID field because I don't want to accidentally send it up to Firebase and have it just add another field called ID. So when you, let's see, where is, yeah. So like here, when I'm taking the document from Firebase and converting it into a model object, you can see the snapshot of the document itself is it's just a map. It is just a map. So I can call get and I get various fields out of the map. But when I want to get the ID, I don't say .get. It's an actual property on that snapshot object. So it's a different kind of thing. And again, like down here, when I'm creating a document where I want to supply the ID, I pass it into this doc function, and then the values I want to put in the document are in the set. Any other questions?
To solve the impact delta's problem, we're repeating the implementation. Not really, because you're not going to make like the location information is still be duplicated for across multiple documents.
Yeah, you would have to query. I mean, you could have like a locations collection, and you'd have to have like a cross document reference, which you could do. Yeah, Solar doesn't do any cross. Yeah. Here you have a lot more flexibility in how you can structure your data here, because you can have multiple root collections, right? So some of the like in the docs, like the examples, they have like a chat, right? Everyone does a chat. So like you have a users collection and you have like a rooms collection, and like a room might have nested messages collections. And, you can have, your users can say, your user document could say, oh, these are the 3 chat rooms that they belong to or they've used recently. And so you can kind of do references that way, right? And query across documents, collections. So you can do that. Whereas in like Solar, each collection is a completely separate thing, right? This is one database with, you can have multiple root collections. Just in my app, I only have the one root collection.
Why did you choose Firestore over a root database?
Because of the document structure.
Okay. Well, I mean, it's similar though. It nested JSON things, right? So
I can't really speak well to real-time database because I haven't actually used it. So it sounded like it was more of a one big giant JSON tree that was a little bit more complicated to navigate. Because I knew like, okay, I need to be able to really easily associate these documents with a user, and I wanted this. It just made sense when I read the docs. I'm like, oh, that totally models kind of how the data looks in my head.
Yeah, I just know that Firestore bills by read writes, right? Whereas real-time database bills by like data transfer. So it seems to do a whole lot of data. Maybe you, I don't know. I don't know. Maybe I don't know.
Yeah, this is true. But first of all, I doubt I'm going to sell this app. But but yeah, but like really, if you're really thinking about it, I mean, I would probably need to put some more thought into the pricing. But I mean, they are pretty high numbers we're talking about. You know, it's in fact, hold on, let me bring up the pricing. What the hell is it? Not authentication. I know the Firestore one has a good pricing page. Here it is. Yeah, understand Cloud Firestore billing. Oh, thank you. Yeah, so like beyond, so you always get the free tier, and then beyond the free quota, then they start charging. So like this is 6 cents per 100,000 documents for reads, you know, so it's not a huge amount of money. And one thing I was reading, I don't remember what it was I was reading, but they were giving the example of like an app that has a catalog. So they're storing items in a catalog as documents. And so they're like, well, you know, every user is going to be loading the same catalog all the time. And it doesn't change that often. So there's two things. One, you can explicitly query the local cache and ignore the backend. So if you know you say, I only want to query the actual Firestore like once a day for this catalog. So the same user isn't like churning through, right? So that's one way to do it, is to use the cache more. The other thing is they have this support for something called bundles. So if it's something kind of static like a catalog, you can actually, through like the admin SDK or whatever, you can actually create a bundle that's basically like just taking a snapshot of these documents as collection, and then you can actually post that on a CDN or something and have your app like pull in these bundles. So you only pay for that once when you make the bundle. If it's something like a catalog, or it's going to be using the same thing.